Have you ever wondered if we could live forever, at least theoretically? Welcome to the mind-bending concept of quantum immortality. This isn't your everyday science fiction trope. It's a thought experiment grounded in the many worlds interpretation of quantum physics. Now you might be wondering, what's this many worlds interpretation? Well, it's a theory that suggests every possible outcome of a situation actually happens, each in a different parallel universe. Imagine flipping a coin. Heads in one universe, tails in another, each universe branching out from the very moment the coin is flipped. Quantum immortality takes this idea and applies it to life and death. The theory proposes that every time you encounter a life-threatening situation, there's a universe where you survive, and another where you don't. So theoretically, there's always a version of you that continues to exist no matter what. So, in essence, quantum immortality is the idea that you could live forever in at least one of these universes. To understand this better, consider the famous thought experiment, Schrödinger's cat. In this thought experiment, a cat is placed in a box with a radioactive atom that has a 50-50 chance of decaying and killing the cat. Until the box is opened, the cat is in a state of superposition. It is both alive and dead. It's only when we observe the cat, open the box, that we force nature to choose, and the cat becomes either dead or alive. Now let's bring quantum immortality into the picture. The idea suggests that much like Schrödinger's cat, we too exist in a state of superposition. In this vast multiverse, there are countless versions of us, living out every possible outcome of our lives. In some universes, we might have already met an untimely end, while in others, we continue to thrive. Much like the cat in the box, we might be both dead and alive, depending on the universe. Now you might be wondering, what does this mean for us? Can we really live forever? Quantum immortality proposes an intriguing notion. In theory, it suggests that we could exist eternally, surviving every possible outcome in some parallel universe. Picture an infinite number of timelines, each branching out to represent every decision, every chance, every moment that could possibly occur. In one of these countless universes, you always survive, no matter the odds. But let's apply some brakes on our imagination. It's important to underscore that this idea is purely theoretical. Despite its captivating implications, quantum immortality does not provide a scientific path to eternal life. It's a concept born from the many worlds interpretation of quantum physics, a theory itself not universally accepted. Moreover, the practical application of quantum immortality faces massive hurdles. Defining death and probability within this framework presents challenges that are yet to be overcome. So, while quantum immortality is a fascinating concept, it remains a theoretical idea in the realm of quantum physics. Like any theory, quantum immortality has its critics. Some argue that the concept wades into murky waters when it comes to defining death within a quantum framework. If we consider death as an absolute irreversible state, then quantum immortality may hold some weight. But what if death isn't so black and white? What if it's a process, a spectrum of states? Then the notion of always surviving in at least one timeline becomes less clear-cut. Next, we have the issue of probability. In a quantum world, every possible outcome has a probability, even if it's infinitesimally small. But does this mean we can equate survival in one universe to immortality? Critics argue that this is a leap too far, an overextension of the probabilistic nature of quantum mechanics. Finally, there's the challenge of proof. How could we ever definitively prove or disprove quantum immortality? It's a theory that exists beyond our ability to test, making it more of a philosophical question than a scientific one. While the idea of quantum immortality is intriguing, it remains a topic of debate in the scientific community.